Hello philosophers and mathematicians. I'm Chico, welcome to my philosophy of math class. Now in case you don't know anything about me, I graduated from the United States Air Force Academy back in 1990, a long time ago. Most people there hated fuzzy majors, right? They broke them into hard majors and fuzzy majors, the fuzzy majors being stuff like the humanities, and they hated them because it seemed like you were at the whim of the teachers, right? They were going to grade you based on how they felt about your performance. Whereas you had these hard majors like engineering that were very precise, and there was one right answer, and if you didn't get it, you didn't get it. Philosophy went under the guise of the humanities. Was that a good argument? Well, it all depends on how the teacher felt about your argument. Whereas math seemed like the most precise, the most hard of the subjects, right? In fact, it's the reason why the engineering subjects were the hard subjects. It made them precise. I mean, it seemed like math is the quintessential, just is what it is, the right answer and no other answer type of a subject. So what could philosophy have to say about such a subject? And why do philosophers get to say it? Why don't we just ask mathematicians what they're up to? You know, I have a vague memory of being in math class in high school, Mrs. Doomquirk's class, and she's one of those like very eccentric type math teachers, you know. She had this ponytail that went all the way down her back, and she looked like she hadn't changed. She looked like clothing from Little House on the Prairie. Yeah, it was really bizarre. Now, I was really good at math, so I was one of those kind of guys, kind of annoying, that could just sort of check out, and I would get an A on the test. And I remember being in class and hearing her say something about 0 divided by 0, and, you know, it was kind of fuzzy because I wasn't really paying attention, and I remember hearing her say that it was undefined. And then I remember thinking, like, wait, undefined? And she probably explained what she meant by that, but I remember just hearing that word undefined and thinking, like, what? Wait. You can't do that in math, right? First of all, 0 divided by 0 obviously is 1, right? Any number divided by itself is 1. What could she mean by undefined? And then it struck me, but wait a second, 0 divided by any number is 0. So this number should be 1, but it also should be 0. But you can't divide any number by 0, right? So there should be no numbers. But wait a second. 0 times any number gets you 0, so really it should be every number. And that was a huge problem, right? I mean, there's supposed to be a right answer in math. Undefined? How can you just throw that word out there? Now, at the time, I was a high schooler, and it was back in the 90s where everything sucked, so I think I just was like, math is stupid, right? So I didn't think anything more about that, but it brings up the question, what is it that we're doing here? How do we get to just say stuff like undefined? Are we just defining numbers? And if so, how is it that the real world seems to fit with our numbers, right? We could send people to the moon and all using these things that we just made up. That seems bizarre. But then our numbers things that we discover? No, they're not like 7. It's not like the number 7 is just floating around out there or something, right? So what exactly is it that we're doing in math, and what are these things called numbers? And that brought me to some other questions that I had back then. I remember thinking, why is geometry math? You know, typically when we're doing math, we get to abstract away from any pictures, right? If I ask you the question, how fast was this car going? I don't have to draw a little picture of a car and show it going. You can just work with the numbers. And yet in geometry, it seems like we're working with these shapes like triangle and circle, and it almost seems like you can't get away from using them. Is there some way to get rid of all these shapes? Or do we have to have shapes? And if we have to have shapes, even though we can calculate stuff, what makes that math? Isn't it some kind of weird hybrid? Or here's another question I used to have. You probably did this when you were in elementary school, right? When somebody says, yaha, nuh-uh, yaha, and somebody says, nuh-uh, nuh-uh, right? And then you finally go, yaha, 100, and ultimately gets to nuh-uh, infinity. And the next step is nuh-uh, infinity, yaha, I guess, infinity plus 1. Right? And when they say infinity plus 1 later on, you find out, you know, some of the older kids tell you, well, infinity plus 1 just equals infinity. And that blows your mind. Like, what? You know, infinity plus 1 just equals itself? How is that possible? You're adding a number to infinity. So, and they tell you, well, infinity is not a number, it's a concept. What the heck does that mean? And they say, it just means all the numbers. All the numbers? So then isn't infinity just like another name for the last number? Well, there is no last number. But wait a second, how can you have all the numbers and there not be a last number? What does that even mean? So notice these are questions about math, but they don't have to do with like how do we actually do math. They're more questions about what is it that we're doing. Now, you might wonder, why is this the philosopher's job to come in here and say what a mathematician is doing? Well, just think about that question. What is math? How do I get an answer to that? Do I go about computing it out? Which, just a second, it seems like, math is 42. Interestingly enough, and something we'll find out as we go along further in this philosophy of math, for you non-mathematicians, mathematicians don't spend most of their time computing in the first place. Mathematicians really spend time proving things, proving what follows from what, but they're proving things about computation, about how to go about computing, or given certain rules in computation, what follows from those rules. But when I ask the question, what is math? I'm not doing that kind of a reasoning. So when I ask the question, what is math? I'm not doing math. What am I doing? I'm doing philosophy. We're asking philosophical questions about math. We're doing philosophy of math. Now, exactly where the line is drawn between what is math and what is philosophy, I think gets a little bit fuzzy, but we'll see as we go along. Personally, I'm not really worried about, this is a mathematician's job, this is a philosopher's job. But I do want to give a caution. The fact that we're asking a philosophical question about math doesn't mean that the philosopher gets to dictate to the mathematician what she can or can't do. That would be like a biologist stepping out and saying, oh, Mr. Frog, I'm sorry, you're supposed to breathe through your mouth or your gills. You don't have any gills and you're underwater, so, you can't be alive. No, it's the biologist's job to observe and to try to explain how it works. In the same way, it's the philosopher's job to observe, to try to clarify maybe, to describe, to come up with theories about what is going on. In other words, you don't get to change the math just to fit your philosophy. Instead, you do philosophy to understand what the mathematician is doing. Now, this is going to be the beginning to a whole class, I'm hoping, of philosophy of math. We'll be going through a bunch of different books. I'll put a link to each one of them in the description. But let me know if you have any questions, and if not, I'll see you in the next video.